Yeah.
weaker point. Yeah.
Awesome. Okay. And can you tell me what you've used with him to date?
So downstairs there's a curriculum called My Homeschool.
Mm-hmm.
So I've been using their maths so far, but I think going into year 3, they sort of shift to using maths online.
Okay.
Whatever that is, and I don't really know what I'm going to do next year.
Okay.
And been using the mental maths books as well.
Mm-hmm.
As a bit of a,
But more
support as well.
book-based
Yes.
learning.
Yeah.
Okay,
Yeah.
cool. Great, thank you. Julie and Alex and Abby, maybe.
Yeah, so we're homeschooling Alex at the moment, and he was mainstream school for a while there.
Yeah.
And they kept assuring me he was up to, keeping up, and he wasn't. So
Yeah.
we're trying to play catch up and give him back the confidence that.
Cool.
And it is working somewhat.
I'm working with a school at the moment, Alex, where on the Gold Coast, where we tested all of their year 7 to 9 students, and they're all finger counting, all like year 1 level maths. They've done 9 years of it. It's just a problem around Australia. So don't ever think that, I think it's such a thing when we're homeschooling. We have this standard like here that's, yes, like we're so dedicated to our children, and we need to know, okay, there's ways that we can tweak their learning that actually suits them. Doesn't have to go mainstream, especially like the textbook approach. Yeah. Was it basically textbook that they learn squiggles, abstract? Alex, is that how you were taught maths? Yeah. Cool.
Yeah, we've gone mainly online for ours, and he seems to be a lot more engaged with the
Mm-hmm.
online version than
Okay.
he ever was any books.
Okay.
My spelling and writing is just disappeared.
It's not great?
No, it's
Okay.
not great. It's a level 1, like close to a 6-year-old or something.
Okay.
Nobody ever watched you.
Yeah, I'll tell you a bit. Like we've just taken on marketing or promoting a program called the Soundway that I used when I was homeschooling. It's like a 6-week intensive. The guy who developed it basically is like, within that time period, you will definitely increase your year levels by 1 to 2 years. Just in that time. It's reading, writing, spelling, and it's the most multi-sensory that I've seen of language. And teachers still in the similar approach, because that's how I heard about them, because they actually approached us when I was homeschooling and said, can you review our program? Because they saw that the way we teach maths is very similar to their language. Like so there's a video to watch, the guy that put it together, video to watch, there's workbooks to work through, and it's amazing. The one thing my girls, I've got 5 daughters that I homeschooled, the one thing that they say they remember in literacy, and it just changed things. Yeah. But we're talking about maths today, but still it's a awesome program. And we just went through it at our pace, so they're like an hour a time or something each lesson, but I was like 25 minutes and we just moved through. Took us longer than 6 weeks, but yeah, cool. And Abby, are you learning anything at home? Other than life? Yeah?
Yeah, she's jumped on with one of Alex's tutoring programs.
Cool. Awesome.
Working through at her own pace.
Awesome. Great. And Alex, what would you like to learn from today? Like being here, next 45 minutes of your life? Like just want to see maybe a different way to learn maths? Okay, cool. Okay. And Lauren, I think you put your name down on the app that you're coming. Okay, cool.
So my big one's nearly 6.
Mm-hmm.
Want to start feeling a bit more organised. We've just been doing life stuff, but she's wanting to do more. She's loving the numbers, not loving literacy, but loves the numbers. So if I can learn different ways to show her different things
Great.
while she's king.
Yes. Awesome. Nice when the mental chatter doesn't tell another story. Yeah. Yeah,
So
cool.
she's showing her younger sister how to count and things like that. Chickens and things.
Great.
Eggs and chickens.
Great. Awesome. Thanks. AJ.
Hi, I'm AJ. I'm dad to Alex and Abby,
Mhm.
and to Julie.
Uh-huh.
starting. Once he's actually doing the maths, he knows that he's fine, but it's a real struggle to actually get him. Wanting to actually like do any work, put in the actual effort to do it, and reading the questions properly. Like he might guess things, but he'll put it in any random answer because he hasn't read the question properly.
Yeah.
Even though he knows how to read it.
Yeah, but all of that is how we would respond if we weren't understanding something as well. Yeah. Yeah. Very cool to see. Hopefully you'll learn today. Okay, so I'm just going to get started. They've actually said that they're recording this, so I'm going to actually go through the presentation rather than just talk to you with this. But basically what I wanted to, first of all, welcome you. To me, what I saw when I homeschooled, so in the year 2000, decided to homeschool our 5 daughters. We actually left Queensland and went down onto a property and wanted to teach them all sorts of life skills, like build a straw bale house and home birth. We started running a business where we actually took on the distributorship of a program called MathUC that you might have heard about, which we currently sell, and we're just in a transition stage where we're actually in the next month going to be releasing our own program that takes in what we've learnt from the last 25 years and the research that actually shows this is the most effective and simplest way to teach mathematics. Hey, welcome. Come on in, we're just getting started. So we're going to talk now, just because this was the topic for today, we're going to talk about this piece of maths anxiety and look a little bit, part of it on a little bit of a technical side to understand what maths differences or difficulty is. But I don't want to spend too much time on that just because of what you've shared, and I'd rather answer your questions and meet your questions. So bear with me, and please, what I would ask is if you've got a question as we're going through, rather than this being a lecture, I don't want it to be a meet up here talking. I'd rather you go, okay, what about this, what about that, yeah? So basically, as I said, my journey from 25 years ago was Australianising the MathUC program and then distributing it to home educators for the last 25 years. In that time, about 10 years ago, I was approached by a school actually up in Caloundra, where one of the teachers was actually a homeschooling parent, had been using the maths program, the MathUC, in his classroom, and only just by teaching sequentially. So they weren't using the hands-on that we're going to talk about. Just teaching sequentially, they were getting amazing results to the point where the school actually said, can you come and teach all of our staff? They'd put all of their students from their entire primary school using this approach. So that was sort of the beginning of understanding there's a different way, and it's starting to go to conferences and seeing research is actually talking about what I'm going to share with you today in terms of this actually is the way to make maths meaningful and maths easy to understand. Lauren, I know you were on the app. Did you see, I know on the app they've got a link to the TEDx talk that I did last year. Did you manage to look at that? No? Okay.
Oh, no, I didn't. I missed it.
Okay. So I know it was taking some time to come up, so it might have just been that. But if you look up TEDx, and it was titled Why Maths is a Simple Language, and I'm going to talk to a little bit of that today, because when we approach maths as a language, what do you think you'll see? Maybe that's not the question. When we approach maths as a language, we'll start to see that the symbols that we'll look at today, so back in the day we used to use Roman numerals, yeah? Now we use squiggles like 0, 1, 2, 3, but those squiggles don't have any meaning in them whatsoever. So let's look at the slides and we'll sort of talk through this a little bit. Okay, so I'm just going to go through this definition. Basically, there's a thing called maths anxiety that basically they've actually seen, and the beautiful thing that I've seen is that even with, there's such a propensity, I don't know if you've seen, sorry I haven't met you yet, but Marianne. If you haven't, there's a propensity in our culture where we want to diagnose, yeah? We want to say, oh, this child's struggling with something, so you've got this. And if you've got this, then we can put a box around it. Sometimes we can work out strategies, but often it's boxes, and then we'll reduce our expectation and even our expectation of ourselves in terms of teaching our kids or finding solutions for them, yeah? So basically, when you look at maths anxiety, even if you look up the word dyscalculia online, it will list a whole lot of symptoms like struggles with maths, struggles with number recognition, has difficulty making connections in mathematics between maths and everyday life, a whole lot of things that you could pretty much put most kids into, yeah? So it doesn't actually give you an understanding where you think, oh, this is the symptom, they've got this. So just because they have these symptoms, what I'm wanting you to see is because they have those symptoms where they're struggling, does not mean that they have dyscalculia, does not mean they have a learning difference, does not mean anything other than they might actually just have a whole lot of stress and a whole lot of tension because they don't understand something. And if you think about yourself, even as an adult, when you've got a situation and you're not understanding, welcome, if you're not understanding something, you've got anxiety about it, yeah? So any situation that we're in where we don't have the tools or the understanding to be able to meet that situation, we're going to have a level of anxiety. So just wanted to share that because this piece where, as I said, we want to label it too much and label too many things too much. And instead of looking underneath at what is the actual cause, which is what we're going to look at today, then we tend to do that rather than go, there's actually a way for us to reduce the anxiety and we can give understanding. Can I ask, like, when you think of how you were taught maths, were you taught maths like yourself as an adult? Were you taught it in a abstract way? Were you taught a lot of like rote memorization? What was it, rote memorization, yeah?
We had the blocks, the 10 blocks.
Questionnaires, sort of?
Oh,
Base 10s?
10s, 1s, 100s.
Okay,
Yeah.
units, 10s, 100s, yeah. And they're all the same colour?
Yes.
Yeah.
They were all wood.
Wooden, yeah. Okay, because there are some that were called Cuisenaires that are still available that are wooden, but they're coloured. And they're lengths, but I think what you're talking about, the block, the maybe MAB blocks? Yeah.
That's the one.
And they had demarcations in them, yes?
Yes.
Okay, cool. So a little bit different to the Cuisenaires, but there are these different ways that we've been taught, but
That ended fast, yeah, that was sort of like lower primary school. I was in Victoria, so you got lots of tactile learning and lots of linking to this is what that number means or this is what it looks like, and then it was rote. Some of that rote to get your times tables in. I remember being in grade 6 and everything's competitive in Australian schools, so except book week, which
Yeah.
is such a shame. So he gave us I think he gave us 7 and something. I know the 7s and I still know my 7s under 10 seconds, and we had it under 5. So he tried to use speed to get us, and so it never went away.
But you were taught by seeing, manipulating, and then going to the abstract.
Correct.
Yeah, awesome. Okay, cool. Yeah, so the piece that tells you is that, you know, when even this phrase we say we learn through a picture is worth 1,000 words, yes? And then we go straight to symbols when we come to looking at mathematics. And I've got some slides here I want you to say, and you'll see if you watch the TEDx talk, I talk through this about look at other languages, yeah? So if you think about, do any of you know a language like Japanese or Chinese or Hindi, or you know some of them? Yeah? Great, okay. So when you look at Japanese, it's got a whole lot of symbols that mean look very different to English language symbols, yes? When you think about those symbols, you could not look at those symbols and have an understanding of what they meant. Same as you cannot look at DOG and know that that's talking about the dog that you've touched, felt, seen, until what happens? Can you think about what happens for that connection to be made?
There's an image.
What's that?
Some sort of image.
Some sort of image, yes. And what comes before the image, or sometimes before the image? Pardon?
The
A
sound.
photo, yeah.
Sound.
A sound, but also the actual animal, yes? So the three-dimensional, I've touched this animal, this is called a dog, everybody points and goes, dog, 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 dog. So we hear it, it's abstract, yeah? What's that? Yes, repetition, and also this piece where those sounds are abstract. In another language like Japanese, like I know in the French language, they say chien for dog. So I could look at a dog, and there are how many languages in the world, different ways to say what that is. When I come to those sounds, they're abstract, yeah? There's no meaning in them whatsoever. Nobody else could hear that sound and go, oh, that must be that. Same as when you look at the symbols mean nothing. So if you think about Japanese kanji, is that what it's called? Japanese kanji, when you look at even French where they use symbols that are similar to English symbols, we would have no clue what those symbols meant, unless we'd been walked through a process to understand what those symbols mean. Okay, let's just look through this now. So I'm going to talk to these. I just want to move through these particular pieces. So when we're going to look at maths, we're going to say, we're going to take ourselves as the adults that are the teachers, we're going to put ourselves into our students' shoes, and we're going to go, they're at whatever age they're at. I mean, Alex, how old are you? 12 years of age, yeah? So he's got a whole lot of life experience, but hasn't necessarily had his brain develop, even to the stage where he can, probably can think abstractly, but it's just in that transition stage. Actually say until the age of 7, if you've heard of a guy Piaget, until the age of 7, we actually can't even think abstractly, which is why primary years, year 1 and 2, we started using manipulatives to show maths. And then we got to year 3 and went, oh, okay, we don't need them anymore, instead of going, actually, when you think about yourself, you probably learn a whole lot of things from actually doing it. I saw this beautiful example of this when we were down on this property in Victoria. I'd wanted to learn how to do some quilting, and read books and saw pictures, could not for the life of me, get myself to be able to make a quilt. I just couldn't understand it. I went and did a one-day workshop. We actually cut the pieces of material, sat there with the sewing machine, sandwiched it between the pieces. At the end of that day, I had a little quillo, which was what it was called, to be able to then go and make it. And to this day, I could make another one because I had touching, feeling, seeing, that whole experience even as an adult. So if you think about the way you learn something, it has to be, I've experienced it. It has to be, I've touched it. It's been felt with my body, this little memory bank that I have, I'm feeling it and knowing it. And that's where the confidence comes. So if we come to the abstract, there's no confidence, because the abstract, particularly if you're younger, and even at Alex's age, I would guess if you showed him some blocks and you went, this is what 3 is. 3 is 3 units joined together. This is what 6 is. It's 6 units joined together. What are they going to be the same length as? You could easily build a 3 and a 6 and see a picture of it, yes? That first picture is going to be then followed by drawing, then the abstract. So when you talked about the image or the photo, something we can see a picture that's now two-dimensional before I come to the abstract, is this link between something that's real and the abstract squiggles. So this piece of putting yourself in their shoes and teaching to learning styles. So what do you understand by the phrase learning styles?
Oh, it's the old auditory, visual learning,
Yeah.
and kinesthetic.
Yes. Perfect, yeah. The visual, the auditory, the kinesthetic and tactile, yeah? So there's touch with my body, I can hear it, I can see it. So using all of our senses. There was a whole lot of research that sort of poo-pooed the idea of learning styles. But when you think about it, if you integrate all of those learning styles in the way you're going to teach a child, they're going to have the greatest opportunity to retain, yes? If you go straight to one, if you go, okay, I'm just going to show you something, I'm not going to let you hear it, or I'm just going to give you the tactile, but it doesn't have the other components, they don't have the same opportunity for success. So basically this piece of going, let's incorporate all of them. Let's go at their pace, which is the awesome thing about homeschooling. You can go at their pace and make sure that we've got mastery. So this is a really key piece. You know, our curriculum, even our maths curriculum in Australia, is what they call spiral based, yeah? We do a little bit of this, a bit of that, bit of this, and hope that as we do little bits of a whole lot of different things that the student's going to understand. Whereas what I'm going to propose to you today and show you is the most effective, because when you look at like somebody like Alex is 12, yeah? He's soon going to be like at a stage where he could actually leave any formal education and go into a workspace. Like, what skills does he need? He's got like 3-4 years before that time. So even this school I mentioned earlier, like imagine being year 9 and you've got 1 year left of school and you're still finger counting. Or you leave school and you're still finger counting and you don't actually understand maths. So when I look at maths, I'm like, what is the most efficient way for us to teach kids? Not what's going to take 12 years and we can fill in time. Like this school, I mean, imagine you've got year 9 students and they're all back at year 1 level. You just look at that and go, what did I spend the last 8 years of schooling doing in regards to numeracy? So that's the opportunity we have when we're homeschooling. These are just components that are known to be really effective. So sequential, when we teach in a sequence, so it's basically this part of going, if I can count, then I'm going to teach adding. If I can add, I can teach subtraction. It's just the inverse, yeah? If I know 3 + 2 is 5, I've got 5 and I lost 2, how many do I have? I can see it visually, I can build it, draw it, write it, say it, yeah? Okay, so I'm going to skip that, but I'm going to go to this part of tools. When you think about, how do I say this? So when you look at research at the moment, have all of you heard of cognitive load or cognitive load theory, yeah? What's your understanding of cognitive load?
It's about ensuring that we get before we go to, that we hit the marker developmentally, regardless of who the person is or what sort of core cognitive expectation you might have. You might have 16 children and therefore every one of them can only handle so much of the pie before their brain allows their brain to digest.
Yes.
It's like napping in under 3s.
Yeah.
Essential to let that cognitive load be processed before they can take the next part.
Yeah. Cool. Okay, so I'm going to just build on that a little bit, or try to simplify that. Cognitive load theory actually says we can, and just think about these numbers, we can only take in between 3 and 8 pieces of information at one time. New pieces of information, yeah? So if you think about that, you go, well, and there's this concept that basically, you know, we learn something or we get presented something. If there's more than that much information, I just won't be able to retain any of it. So between 3 and 8 is standard. If you've got learning challenges, then it's even less than that. So only 1 new piece can be, or 2 new pieces can be introduced. But imagine 3 to 8 new pieces of information can be retained at a time. What happens is when we teach sequentially, we can actually ensure that we develop what's called schema, where we're actually creating chunks of information. Like if you think of counting, yes? If I can count from 0 to 9, now that I can count from 0 to 9, I can teach place value, because in each place, you know, our hundreds, tens, units, in each of those places, I have to be able to count from 0 to 9. It's our whole base 10 system is based on that. So if I can count 0 to 9, now I can teach place value. If I understand place value, now I can teach addition, which is instead of me going 1, 2, 3, 4, 5, I can see a 2 and a 3 and say, this has got 3 symbols in it, a 2, a plus, a 3 symbol, another equal symbol, and a 5 symbol, yeah? So with just 5 symbols, I can actually show that part, and it's the cognitive load, though, is there's a simple progression from the counting to now adding, yeah? So once I can then add, now I can do the subtraction. I'm just using the same representation. Now I can teach the inverse of the addition. As I said, 2 + 3 is 5. If I've got 5 and I lost 2, or I owed 2, or I gave away 2, or whatever other life application, then I can now teach subtraction, yeah? If I've got adding, now I can teach fast adding, which is multiplication, yeah? So instead of me going 1, 2, 3 plus 1, 2 is 1, 2, 3, 4, 5, I've been able to go to addition. Instead of when I'm adding, say I wanted to add 5 plus 5 plus 5, I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, yeah? A whole lot of time to do that. If I'm adding, I've got 5 and 5 is 10, and 5 more is 15. So our next step is let's multiply. Here's 5 and 5 and 5. So I can build a rectangle that's 5 across, 3 up. It's a much quicker way of seeing it, and it's this do you see it's like this next progression from adding 5 and 5 and 5, and the way beyond the counting. So like second step from like, you know, lesson 2 in year 1 is, lesson 1 is counting, lesson 2 place value, lesson 3, what are these blocks? What's this representation that we can use that's going to be able to enable us to teach maths? Now we can progress beyond that and we don't ever have to come back to counting again. What happens is we might understand the need for manipulatives or hands-on learning, but then we use manipulatives or a way of representing that keep reinforcing the unit counting. If you think about, you've all seen 10 frames, yeah? You see like 2 rows of 5 dots, yeah? What system is our decimal system? Base 10, yeah? So I look at it and go, why are we teaching 2 rows of 5 dots? When we've got a base 10 system, we can teach straight to the base 10 system, especially if we have a tool that can make that progression very simple. If you think about other pieces, even something like dominoes, yes? And this part where I was saying before, put yourself into the shoes of your student. They're looking at this domino dominoes are awesome. Like, all these pieces are awesome in their particular space. But when you're wanting to teach maths, you're wanting to do it really effectively, efficiently. When you look at a domino, it's a rectangle divided in half. On one part of the domino, it will have like maybe 6 dots, yes? On the other part of the domino that's exactly the same size as this 6 dot part is 1 dot. Do you think that that's showing a student the difference between 1 and 6 when you put yourself in their shoes? Not what you know that 6 is bigger than 1. You could look at that and go, I could use that to teach, you know, here's more dots on here than there are on here, but that's all I'm teaching. I'm not actually teaching a sense of number and what is 6, what is 1, because if I put the 1 and the 6 together, if I use the dots, I'm going to reinforce I need to count or use my fingers or count by ones or remember a pattern. So it's way too much cognitive load taken up if that's the only model that I'm going to be using. Okay, so I'm going to show you some tools. You'll see I've got some here. I've got some downstairs if you want to come and look. And in the next session, I'm actually going to we're going to get the blocks out and we're just going to work with blocks, because these tools mean you can actually progress a student through counting, place value, adding, subtracting, multiplying, dividing. Then take that same model, you're just building a rectangle. Everything in maths, everything can be shown with a rectangle, yeah? So if you look at cognitive load, and remember the cognitive load piece, and the part we learn through pictures, yes? Like if you see, even if you see these TOOLS, you see a picture of a tool, some tools in your head when you see that word. If you see the word dog, you see a picture of a dog, which is exactly how the process we walk somebody through to understand what does DOG mean. Because in the, other languages, they'll use other symbols. But basically we're wanting to show, let's have understanding. We're going to touch and feel and see, just build rectangles and take that model, all of those operations into then fractions, decimals, percents, and algebra. So imagine I've got the same model, I'm just building a rectangle, I don't ever have to bring in however many other representations, and I can teach understanding. I can use cognitive load to my advantage and go, this is understood, now what's the maths piece I'm going to be able to teach? Yeah? Okay. I'm not going to walk through this right at the moment, but I do want to just show you, basically, we're using, these are just different representations of the same blocks. These are some blocks that actually a special school I'm working with in Melbourne, actually 3D printed these based on our other ones. 3D printed them because there were some kids that, you know, if you can imagine, kids that have physical challenges as well as mental challenges, but this is way too small for them to pick up, yeah? If you've seen the Math UC ones, they're like about 2/3 the size of this, so they're even smaller. So this, and then basically they 3D printed, as I said, I've got some downstairs so that the kids can actually hold them. At this stage, they only printed up to a number 5 because they were like, our kids have never progressed beyond that. We're now like 7 months in and they're just about to print to the bigger ones because they're seeing that the consistency, and this comes back to cognitive load again, the consistency of the model, it's like it just rests the brain and goes, okay, I know this is going to be accurate. I've felt it, touched it, seen it. I've had the 3-dimensional. Now I can go to I'm going to actually draw a picture and then go to the abstract after the picture. These are these ones, and then we've got some magnetic ones that actually are able to be used on a whiteboard or a fridge or whatever to teach. So I just wanted to show you that just to see this same model can be used to teach all operations and the part where we're just using colour to differentiate. So if you think about colour, I mean, this is one of the key pieces, you know, the MAB blocks question, yeah? The colour is used because, as you can see, the colours are very different, yeah? When you look at, I mean, I've had was talking with a professor of maths about this, and she was like, oh, you couldn't possibly expect kids to be able to remember the colours, yeah? It's the fastest thing that they do, yeah? And the piece of knowing we actually use colour in our life to differentiate. When you think about, like, simple thing is look in your wallet, you want to see a whole lot of green ones rather than purple ones. So like what use are they these days anyways, almost, yeah? I mean, I can't even buy a coffee with a purple little one. But that gives us a picture. When I look outside and there's blue up here and green down here, I'm like, okay, there's something, my brain doesn't have to take energy to process it again. It's basically that understanding that says, if I use the model consistently, the model's always going to be true. It's always going to be accurate. I don't ever have to question, is this going to be an accurate representation? So then I can actually get on with, as I said, with teaching the maths part. This is just showing, like, we actually use them on the underside hollow to show subtraction. And with this particular kit that I said, as I said, we use the whole way through. There's a little booklet that you can download that walks through as well sequentially. This is just the progression into fractions and decimals and percents. But I wanted to just, can somebody give me the time? I just wanted to see how much I've got to. 10:32. Okay, cool. I'm just going to, first of all, are there any questions or just comments about just what I've talked about? No? No?
Well, I have a million, but I'll keep learning.
Okay. No, ask the question. I believe.
It's homeschool, so I'm being very specific. So
yes.
Apologies.
No, it's homeschool.
My son learns. I'm a Montessori teacher, so everything that you've said, I'm right on board with.
Yes.
Right? My son does not learn tactilely. He doesn't get it. He needs to watch a video. He needs to watch a video and then do a worksheet. My Montessori so you really need to stop that. Right. So, and then we can introduce. So, you're quite right. Like when you pull them out and they're already neurodiverse and nothing makes sense, none of the reports make sense, so you don't actually know what he knows and what he doesn't know. There's echolalia just to ensure that I have no clue as to what's going on behind that, because I can get every episode of any television show that he's enjoyed, including the accents, verbatim. I just can't get him to say, yeah, I get it. Yeah? So that I can move on.
Yeah.
Which I can most days, but generally I'm getting this. I like the colour thing, and I want to link that back to number blocks, and that's fairly simple because it's the rectangle and they break up and they show him and he knows every episode of that. So, so we can count and we can add and we can do. I know that because when we expand into something greater than, when we start building on these cognitive areas and we assume that it's limited because he can't, like, the measurement is different.
Yeah, yeah,
The me-
cool.
So that's the gap I'm trying to
Yeah.
bridge.
Yeah,
And the math anxiety I get, but it's my math anxiety as
Yeah.
a carryover rather than his.
Yeah.
So how do I bridge that part so that he doesn't want to keep going back to what he knows and
yes,
to get that?
awesome. Good question. We'll look at it after I talk through this methodology, yeah? Okay, so most of you probably, whether you've heard about what's called CRA or CPA approach, you probably use it in how you teach. So basically, I'm going to walk through.
Is that like the old CPM books from
No,
years ago?
no. Basically, so I'm going to talk through this methodology. Basically, I developed it after looking at what is the sequence of instruction that's needed when we're actually teaching effectively. So you can go, you know, everybody craves something, so it's a simple model for you to remember however you're teaching. So first piece is, even if you've got a paper, if you can write down I crave, up and down, vertically. And basically this you'll be able to, we've actually got a QR code that will actually send you to a page where you can actually download this complete model that I'm going to talk to you about. But basically this, talking to what you were saying, this part of identifying, like, and when we look at the cognitive load, we're going to actually look at where in a sequence of instruction is my child, have they mastered to? And when I talk about mastery, I'm going, can I take a life question? Could I build it, draw it, write it, say it? Yeah, I want to be able to do all of those. I want this fluency. So I want Alex to be able to go, hey Alex, there were like 7 kids in the pool and 5 of them left. How many kids are left in the pool? What's that? He's got it. Yeah, cool. And I want that fluency, you know, how that automaticity that he had. And I want to be able to go, well, I'm going to write some squiggles on a piece of paper. Can you make that into a life question? So that, to me, is mastery. I can look at life, make it into maths, look at a maths squiggle, and make it into a life question, and have that to a level of fluency, yeah? Very simple in a sequential framework to see where has a child mastered to. Where is it that they're confident, they can go through these questions, they've got no problem with the questions, great, let's go on to the next. So we're going to walk through the sequence, as I mentioned, the counting, to place value, to adding, to subtracting, multiplying, dividing. Now that I've understood all the whole numbers, now I can go to fractions, decimals, percents. Very simple. So I think whoops. This sequence that I was just talking to. The next piece is the C, the concrete. And as I said, we'll look at this in the next little workshop. But this is the model that we're going to use, the blocks that I can feel these. So I could say to you, okay, close your eyes and I want you to feel if this is 1 unit, what is this? And you can count all the way up to and go, that's 9. And to see this is what 9 is. The symbol on the piece of paper, the squiggle, is not 9. It's a symbol that I use to represent this. Yeah? And this is going to be accurate whether I'm, you know, when I'm teaching, you know, if this was the size of 1/5, this will be 9/5. If this was 1 banana, this could represent 9 bananas. So we're teaching to a unit of measure. That means we're not actually teaching to a specific examples. We're going to say, give understanding, we'll be able to broaden it out to whatever else we're learning. So the concrete is the first point. When you look at how you taught your kids to speak, you were like touch and feel, and you know, the dog example. Here's the dog, now I'm going to attach a word that's abstract to it, and then a symbol that's abstract to it. But if I've got that experience with the dog, that last part, the abstract, is going to be way simpler than if I've never even seen it before. Yeah? So the concrete is this beginning place. Then we go to this representation piece, and this is the key piece, which is partly why us developing our own program, which does actually in fact have video, like we've got video where I'm teaching and demonstrating, and then instruction material and lesson plans, and then student worksheets that walk through this actual process. But basically, the representation part is I want the child, once they've built this, so say they've built, this is 9 plus 1, yes? 9 plus 1, I'm going to bring them together. What are they going to be the same length as or equal to? They will only be the same length as or equal to a 10, yes? There is no other number that they will. And once I built it, I know that. I can see it in my mind's eye. This part where I'm going to actually have them draw the picture bridges from this that's three-dimensional to the abstract squiggles, yeah? Do you see sometimes for kids that jump is way too big? I might even be using some great manipulatives and then I'll go to the squiggle and they're like, how on earth did this get from this to these symbols? Like, it's like Japanese on a piece of paper. We wouldn't expect an adult to do it and understand it, but we expect kids to do it every day, yeah? So this part, super important. The other piece that's important about this, and I talked to this on the TEDx talk that I encourage you to watch, is this part where they draw the picture. And it has to be proportionately accurate. So if they draw, I mean, I saw a book by a dyscalculia specialist, so this is a piece to go, so important for us to question bits, yes? Because they had a picture of the number 132 and they said, okay, 132, the abstract. Here was the 100. The 3 tens were about the same size as the 100 and the 2 units were an oversized 10 block size, yes? That picture has just messed up that student's opportunity to understand a base 10 system, yeah? So this part here, the representation that we want them to draw has to be accurate proportionately. And once they do it a few times, it's like, okay, that's the bridge to the abstract squiggles. So the third part, which is the symbolic stage, we actually say that's our last port of call, even though we've been like talking, so they're hearing abstract words and we're showing abstract symbols. This is when they get to actually get to the symbolic stage. So they get to write, once they've built this, and then they've drawn a picture of it, then they write 9 plus 1 equals. Whether I write it this way or this way makes no difference at all. I actually know what each of those squiggles mean. You know, even if you think about, if you write on your piece of paper 9 plus 1, if you write it this way or this way, you've still got all of the same symbols in, yeah? Even when we write it vertically, your 9, your plus, your 1, you've actually got an equal sign within that, and inside the equal sign, rather than on a single line, all of the symbols are there, but the symbols need to make sense. Okay, and then this piece, so I'm just going to actually show you this with the blocks. This is what we'll get to do in the next workshop, but imagine you're doing this. This is our concrete. We're going to actually build it. We're going to get these blocks and we're going to go, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah? They'll count it. They're just learning the names that we give them. Then we get them to draw the picture and then go to the abstract. So do you see that sequence? Like, once I get to this, last step, now there's something I can tag it to. Okay. This is like that next step of integration where I can go, well, find me a block that's the same length as 2 units joined together. This is 1, 2, this is 2. I'm going to walk them through building it, draw the picture, write the abstract, yes? So even that step means when I see this symbol, I see a 2 orange block. That's what 2 is. Like when I write DOG, when I see that, I see the picture of the dog, yeah? As I said, we say pictures are worth 1,000 words and then we go straight to squiggles on a piece of paper for maths. But so basically you're seeing this here. Okay, we'll do this in the next. So yeah, that's basically what I wanted to cover. I mean, I think we're probably at our time, but basically the key pieces that I want you to see is there's actually a way to teach maths that takes in a whole lot of understanding of how we know we need to teach anything effectively, yeah? When you think about how we teach English, especially there's much more conversation now around, you know, this is something we're needing to teach how to decode. Like, it's not okay just to teach memorization of words that used to be the way that we were teaching English, yeah? So when you look at that and go, oh, maybe with maths, imagine if I could do exactly the same with maths. Imagine if I could have a body memory of it. I've touched it, felt it, seen it. Then draw the picture, then write the abstract, same as I would if I'm teaching a child English. I mean, if you think about it, like when one's little, the dog's there, then you show picture books, dog, 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 dog. Then you show movies, tell them about the dog, and then now let's write the abstract, dog. Now we can sound it out. That process we can take into teaching maths and make maths so simple to understand. And because of the fewer rules and way fewer exceptions to the rules that we have in maths, it's like the simplest language, which is why the TEDx talk, we called it Why Maths is a Simple Language, yeah? And if you can take that approach and go, there's no wonder my child might be struggling with maths, because maybe I'm going way too quickly to the abstract. Those squiggles aren't meant to mean anything. Like, imagine if we used Roman numerals, there'd just be squiggles that wouldn't mean a lot, yeah? So if you can take that approach and go, maybe there's a different approach I need to take, a different way, and that short explanation I gave you of the iCrave methodology basically encapsulates and says, let's identify first of all in this sequence wherever you mastered to. Now I'm going to start with something concrete, then I'm going to actually have you draw a representation, then we're going to go to the abstract. That process then means once I look at the abstract, I can see the picture in my mind's eye. And even if you think about, like, if you can imagine, like if I was to say to you, what's 15 times 27, and you hadn't memorized 15 times 27, probably all of us in our head would get out a piece of paper and a pen and go 15 times 27. Yes, that's what everyone would do. And then we'd put a line underneath and we'd try to remember all of the bits as we did all the calculations from the smallest to the largest. And then we'd hope that we could remember them all to be able to add them up and come up with the exact, or else we'd just go to a calculator and hope that we had an idea of the answer. But what I'm proposing to you is, if you could imagine, you could actually build that in your head, like 15 times 27, I said? 15 across 27 up. Already I know I've got 10 by 2, I've already got 200. Then I've got 5 here times 20, so I've got another 100 here, so I've got 300 and something. Already I'm streets ahead of what you're trying to write with a piece of paper in your head, yes? And that process, I can actually see it, I have way more confidence in my answer, and I can come up with my answer with the knowingness, this is what the image is or the picture is of those squiggles on the piece of paper, or of the abstract that somebody said, or the abstract from my everyday life. Yeah, so questions. I know you had a question.
My question was just what time your next session is.
Oh, I think it's,
There's a bit of a gap, I think.
there's like a half an hour gap or something. Yeah, and I think we're actually going to be somewhere different because we're actually going to be working with the blocks. Yeah, so if you want to come along, because we'll have, yes, definitely, 100%.
So I've got here, is that the practical techniques, is that you were saying?
Mm-hmm.
Yes, and that's at 11:30 and it's in Learning Space 1.
Okay, which I'm not sure where it is, sorry. I'll be able to tell you when I'm there. Yeah, but do come along and definitely bring your kids. I mean, it's this piece, as I was saying, like there's a simple way for us to teach maths. We do it way too hard when we go to abstract. Like even as adults, we don't learn going straight to squiggles. If you think about, think about subjects that your kids love, like science, if they're doing it and experiencing it and something's happening in their body knowing, yeah? So what I'd encourage you to do, come along and I'll show you how to do the same thing with maths, and we'll probably have time to actually look at this. Let's count, then go to place value, and then even into addition. Maybe do some subtraction, but I think it's only a 25-minute. So if you're going to come, if you can arrive early, and I'll just have blocks out, and we're going to actually start going through this model that I told you, the iCrave. So we're going to assume that you don't know maths, so we'll start with counting and start progressing through.
Can you tell me what the V and the E stand for, just to
Oh yes, yes. So the V is the verbal, so we're just reminding ourselves we need to have that verbal interaction with the student, and the E is explicit. And when I talk about explicit, like, I don't know if you're looking at news on teaching maths at the moment, but there's a whole lot of talk about explicit instruction, which seems to me to be going more into a piece of classroom management style, like hover your whiteboards and let's all use whiteboards and let's all show the teacher all at the same time and all of those pieces, instead of looking at what does the word explicit mean. Explicit just means accurate and clear. So when I talk about explicit, it's like every part needs to be accurate and clear, so that, like that example I told of the dyscalculia specialist who's saying this is a representation of 132 and it's completely inaccurate. Like making sure that we're teaching, or following a system that somebody who's had that attention to detail has shown to be able to go, let's actually progress them through. Yeah.
What was the V? Half the
V is the verbal. Yeah. Yeah, so if I'm going to be downstairs, I've got a little stall that's got these blocks, and happy to talk with anybody. I didn't mention it, I've mentioned a tiny bit before we started, but basically I started this journey 25 years ago when I saw Math UC, which was a maths program, and started distributing it, Australianised it, and then we've just completed development, or just on the edge, like 30 days from completing, having that available in an Australian form, but that's taken on a whole lot of understanding and experience from the last 25 years to put it into a model where there are videos for a parent to watch, instruction material for you to read, and then student material with the manipulatives that leads you through this process very, very simply. Yeah, so feel welcome to come along.
Thank you.
Okay, you're welcome. Cool. Esther, yeah, Esther White. Yeah, and if you, the TEDx, as I said, was Why Maths is a Simple Language. Yeah, it's only 16 minutes of fame, but it's worth, like the 16 minutes I cover a few pieces that, even as I was saying, like if you can just grasp that piece, it's a language, maths is a language, it's a tool that we use to be able to communicate. And if you think about, square root signs, capitals that we use for speaking about lines, sometimes we use lowercase letters for speaking about lines.
That's like that's how I see it. It's another language.
Totally.
Whereas my husband and my son, like when you said that maths thing, he would have called out the answer straight away.
Yeah.
He just has that. And my dad
Yeah.
was a builder, and my dad did this with me.
Yeah.
Had a tutor for a year and still had none the wiser of fractions, and my dad sat down and cut apples up and
Yeah.
and
Yeah.
taught me, which school didn't. Like when you were saying about putting in pieces like tens and to break up the maths equation. I never got taught that at school.
Yeah.
And that's how his brain works.
Yes.
I'm like, wish I just knew it.
Yeah.
Like,
Yeah.
the concepts. It's
Yeah.
really good.
Yeah.
When you gave that example and you went, this is the way you probably saw it, I went, no, I just, did 20 times and broke it up into the tens, because the 10 base has been our base for so long. So,
Yeah.
my
But still
21-year-old
abstract.
would look at that and go, Mum, you break it up into 10 and then 5 because it's divided by 2.
Yeah.
And she would do math that way. I just can't figure out what the little one is doing. And
Yeah.
I have an 11-year deficit between the two. Old mum now, they're going, can't you just see that that's
Yeah.
that? And he
Yeah.
quotes Mickey Mouse at me, and I don't know if he got it.
Yeah.
We've only got a year gap between them, and same situation.
Same.
you're in.
Yeah.
Different styles of learning.
Totally.
How to visually set. She's very artistic.
Yeah.
Creative.
Yeah.
Yeah.
So
you're
the art
amazing.
creative will be able to see in pictures
Yes.
and learn through touch.
Yeah.
Like your whole world's probably like experience it, yeah? And even female hormones are like, we'll learn through experiencing and feeling something a whole lot more. But I think it's also the same for young men. Like get some building out, it's like there's a whole lot of learning that's going to happen there. But it's like this piece, it's just a tool to communicate. And those squiggles, the squiggles we use don't mean anything, they never were meant to, but can we relate it to everyday life and bring understanding? And simplest model is build a rectangle. Rectangle's going to be consistent. We see rectangles everywhere, we're familiar with them. Is that how you see maths? Do you look in, you actually picture rectangles?
Oh, I'm not really rectangle, but I just see shapes.
Yeah. Yeah. Yeah.
His dad was an accountant and he's really good maths. It's all the way down and then she's like me. And it's, you've got to show me, you've got to feel
Yes.
it, you've got to touch it.
Yeah.
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 And the frustration. So when she was saying.
You're welcome to
squiggles,
go if
she
you need
I'm
to
so
go.
sorry, it's just the next session, but this
Yeah.
is good.
That's all it is
Thank you,
symbol.
Esther.
Until you identify what symbol actually makes sense.
Yeah.
Yeah. Yeah.
Cool. I hope that was helpful.
Yes, thank you.
Feel free to come ask me any other questions. What was your name, sorry?
Carly, they come and find my name badge downstairs. I'm like, I was supposed to be up there 20 minutes ago.
Ah, I think you put your name in the app, yeah?
Yes.
Yes.
So I'm a teacher and a tutor.
Mhm.
And
Great.
I do English and maths for primary school kids, and I absolutely love it. I love teaching. I just hate 30 at once.
Yeah.
So tutoring, I'm working one-on-one with kids, and I absolutely love it. And that's I totally related to everything you were saying.
Yeah.
I get the same buzz from it that you do. And
Yeah.
I love the challenge of finding how they learn and then presenting it so they go, oh. You
Light
just see
bulb
the light bulb
moments, I
come on,
know.
and
Yeah.
so
That's
good.
what life's about, seeing the
Yeah.
light bulb moments.
Yeah,
Yeah.
exactly.
Yeah.
So yeah, it was like being back at uni without the pressure. It's great. I love it.
And are you homeschooling yourself or you're supporting people that are homeschooling?
To be honest, I was curious about, like, I shoved business cards in my pocket, and I thought I'm going to go down and have a look and just see how it all works. And if people are looking for a bit of extra help with
There would be
maths or
so
something.
many people that would be, you know,
Yeah.
to me, like if you're amazing at teaching maths and English, I mean, many parents like struggle,
Yeah.
particularly with numeracy. I think as
Especially
a
if they're
culture,
old school too, yes.
and as a culture, we're more literacy fluent
Yes.
in numeracy, and we've made up this thing. Oh, it's okay to not be great at maths, but everything else.
Kind of need it.
Yeah.
My
Yeah.
mum said everything is science and maths, so you have to be able to understand at least one of them.
Totally. Yeah.
Yeah.
Come down to the.
I will. I'm going to stalk you like I'm
Great. Do that.